Hello guys, in this quick tutorial hopefully I'm gonna show you how we can create this particle advection using Houdini. I'm gonna start off by creating simple pyro sim, simple particle simulation, then we're gonna go to the karma, we're gonna render this stuff, and then we're gonna composite this using a new Copernicus in Houdini. Also, if you want to get access to this final scene file, the link is going to be in the description. So let's start off by creating a source points. So we're gonna create a circle. In this circle, we're gonna set it to the polygons, ZX plane, and we're gonna give it like about 3 points here. So next up, what we need to do is we need to give it some normals here. We want the x-axis here, so these, so basically pointing outwards here, and I'm gonna animate this using attribute fop. In this attribute fop, let's start off by getting the position, adding this normals to it, and then we're gonna pipe this out of the position. So basically it expands like that. We want something more fancy, so let's create the integer to float. We're gonna create kind of like normalized values around these points. I'm not gonna go too deep into this because then tutorial is gonna be very long. So, and if we just look at this, basically have 1.5 and 0 here, so basically like a curve view attribute along the curve. Let's add to this value a time, and then we're gonna pipe this through a sine node, and this sine node we're gonna fit range this. We're gonna basically say -1 to -5 to 0.5, just kind of set the range here. And what we need to do is we need to take the normal here, and we're gonna just multiply this normal by this value, so that way you get this, basically this type of a animation here. We want 125 frames. In my case it was like this, and then you wanna use the transform node, and wanna set this $f multiplied by 4, so it's just basically gonna rotate like this. Next up, we're gonna give it some velocity, so we're gonna use point velocity node, and then we're gonna give it a p-scale because we're gonna need this for the simulation. The p-scale in my case it was 0.4, so this is basically your source points. Let's start off by creating a VDB volume. So when I use VDB from particles, it's gonna take the p-scale here and make like a spheres from those points. Let's set the voxel size, and also we want to have a fog VDB, and we'll also want to rasterize our velocity that we created here to the velocity field, as you can see here. And then next up is of course the Pyro Solver. Pyro Solver, we're gonna have the same voxel size, and we're gonna just relative reference this back to the VDB from particles. In here, I'm gonna set the ground plane close below. That way we're gonna have some collision in the ground. And also if you go to sourcing, I don't want any flame. I want to take temperature from the density, so it's going to be the same. The source velocity scale is going to be -1, and then also our volume is called velocity because we set it here, so I'm going to rename this to velocity. This is going to be set to 5 in the field. We don't want any flame here, of course, and I want to set the dissipation a little bit lower. But in the shape tab, I'm going to set this buoyancy scale so it goes down, kind of acts like a gravity. And then disturbance is 0.2, and the turbulence is 0.1, but the swirl size is set a little bit lower, and then the pulse length is 2. In the look, we don't want any fire, we don't want any material here. And then in the output tab, we only want to output density and velocity. Let's tick this off, let's tick this on, so we do want to convert this to the VDB. And also we're gonna use clean node. We're going to delete every attribute except the name, because we want to have correct namings in our VDBs, of course, so that's why we don't delete it, but we delete everything else here. And let's use a file cache node. I'm gonna call this cache pyro, load from this, and let's just cache this out. Let's now create a particle source. So we're gonna use, in this case, copy to points, and we're just gonna copy a simple sphere with 8 frequency to our points. That's what we get. And then what I want to do is I want to clip like below this plane. So I'm gonna use the clip node and set this to 1 like this, and then I'm gonna use scatter node. In this scatter, I'm gonna scatter around 100,000 points. I want to tick this off, I'm gonna tick this off, and I'm just gonna use a random seed based on the frame number, so it's gonna be the different each frame. And also I'm gonna use a rest node to give it a color in the later stages. And of course I want to use a blast node here, so we get our volume as you can see, but what we want is we don't want any velocity, we just want to get our, we don't want any density, we just want to get our velocity here. And let's create a pop network. Let's connect this up. In the pop network, nothing is crazy here as well. What we're gonna do is we're gonna create a ground plane, we're gonna connect this up, and then we're gonna delete this merge here. We don't want this. In the source tab, I'm gonna source all my points. I'm gonna set this to negative, and that's pretty much it. Next up, I'm gonna create pop advect by volume. I'm gonna set this to second context because we connected this to the second input here, and I'm gonna set this to date velocity. We get the ground plane as well, but we don't really want that, so we're gonna just say we only want to take this pop object here. So I'm gonna say pop and then the star. Basically every object that name starts with the pop going to be imported back to the scene. And then if you hit play, you get this simple fast particle advection. We're gonna cache this as well, so I'm gonna use cache particles, and let's cache them out. But before we cache them, we're gonna delete again all the attributes that we don't need. So let's untick those, and then let's say we want to have an IDs, we want to have a rest attribute, we want to have a velocity, and we want to have a age, and then the life. We're gonna use them later. And then of course let's cache them out. Let's create a simple flipbook particles. Let's create a camera here, and then we're gonna just set this like this, and then maybe 36, and then the 80 focal length. And if you look to this camera, I'm gonna set this aspect ratio to square, and then in here if you click right click, you can set this to pixels, and of course nothing is visible. Let's create the attribute adjust color. We're gonna create this noise, and then the location attribute is rest that we created here. So basically now our noise will be stuck to those particles, which is cool. I used the warping here, and then what I'm gonna do, I'm gonna use the same colors that I had before, just so we get the same result. So I use colors like this. I'm gonna just quickly input them. And I also up the contrast just a tiny little bit here, and that's pretty much it. Let's create the flipbook of this simulation, see what we get. This is the result that we get. As you can see, quite nice. I want to have a little bit of retime on those particles. So what I'm gonna do is I'm gonna set retime here, and then I'm gonna say input frame. So basically I'm just shifting those out with the retime here. What I need to set is to post extend, and then here the velocity on the frame 1 is going to be 2, and then in the frame 25 it's going to be 0.3. And let's hit keyframe with the alt button, and let's quickly make flipbook as well. And after the flipbook is done, this is what we get. So it starts off fast and then slows down, and it looks kind of cool. The only issue we have is this popping right here, and that's because our particles are born every frame and they just like pop out of nowhere. So I'm gonna fix this, but before that I'm gonna use attribute randomize to create random orientations on those points. So I'm gonna say orient is 4-dimension vector, and then let's use the seed attribute here, and in here I'm gonna just set this to direction or orientation. That way we're gonna get the random orientation. Later down we're gonna just copy instance like chunks to those particles, and this is going to be really helpful to create those like random highlights on the particles. And let's start off by creating our setting size of our particles. We're gonna do that with the attribute noise, and first thing that we're gonna do is we're gonna create constant node, and then let's create bind export node. I'm gonna export as a pscale, and then in here you can just say promote parameter, and this is going to be our base scale. The base scale in my case was 0.04. To visualize this again, okay, you need to right click here and set this to lit spheres. That way you get like a point visualization here. Give this a little bit of randomness. So I'm going to start off by taking our IDs and getting the random values from those IDs, fit ranging them from, we're going to basically multiply this from 0.5 to 1. You just multiply this. What you get is you get a little bit of variations here. Next up, what I'm going to do, sum of the particles is going to be twice as large. So I'm going to use a multiply constant and multiply this to 2. And as you can see, particles become bigger, but I only want like a 10% of all particles to become this large. So what I'm going to do is I'm going to take another random here and I'm going to pipe this add constant here. So basically I want to get a different seed from this random to this random. So I'm just going to input random seed here. I'm going to just use compare node and I'm going to select basically less than 0.1, okay, 0.1, which is basically like a 10% of our particles. I'm going to use integer to float and I'm going to use a mix node to mix between original position and then this twice as large, and I'm going to use this as a mask. And as you can see, some of the particles become larger, which is pretty cool. That's exactly what we want. And then to get rid of those popping in particles, what we're going to do is we're going to use this age. We're going to divide this by life. So we're going to create this like when the particle is born, basically it's going to have a value of 0. Then slowly it's going to like become bigger and bigger. So that way we're going to use this fit range. So 0.01. This value is come from the life basically. If you divide 1 by 100, you get 0.01. So this is where I got this number. And then again, you just need to multiply this by that. And as you can see, those big chunks like disappear because they're gonna basically become bigger and bigger over time. So let's create a flipbook. And then what we can say is basically we're done with our particles. Let's call this out pt and let's create the flipbook. This is the result that you get. As you can see, we don't get any pop-ups here. The particles moves really nicely. This is a little bit of a compression from my part because I'm using a remote desktop at this moment. And of course, let's get to build the chunks that we're gonna copy to those particles. We're gonna start off by creating a box, simple box here. Let's create a velocity volume, fog volume, and we're gonna copy scatter actually spheres inside of this object. So I'm going to use about like 15 maybe, and I'm going to do Voronoi fracture. Okay, and then let's pack those. So we're going to use assemble node and let's create packed primitives, and then let's blast points. But right now there is nothing to blast because what we want to do, we want to have this outside group to be just transferred to those packed primitives, and we're gonna just delete this outside group and also delete unused groups. Let's use for each primitive block, and then as you can see we got this chunk. So let's use a match size. I'm gonna match size this to a sphere because our particle is basically the size of this one sphere, and I'm gonna say scale to fit, and that's about right. Then what we're gonna do is we don't want everything, every like 22 pieces. We only want some of them. So I'm gonna use a random selection node from labs. I'm gonna set this by count, and then I'm gonna select about 3 of those chunks, and I'm just delete non-selected. Then what we want to do is you want to have a blast node, which is just basically saying isolate first chunk and then unpack it. And then also let's clean all attributes from this chunk except the normal. So we want to have a normal here, and then this is going to be basically piece 0. Let's duplicate this 3 times and then select first point and then the second primitive as well. These looks like the same for me, so what I'm gonna do is you can use align and distribute node to just like visualize those chunks, and then you can just, for example, play around with the seed a little bit. This is something for me. So we are basically ready for rendering. let's get into it. This is our particle setup here. Next step is let's create a loop network, and this is going to be render. We're gonna start off by basically setting up our instance collection. So let's use a SOP import node, and let's call this import piece 0, and then in the SOP path just select piece 0, right? And then the import path prefix, I'm gonna just put this into the instances piece 0. And to better work with the Solaris, let's switch to the Solaris network, and then I'm gonna go back to our loop network. And in here, as you can see, we have instances, then piece 0. Let's duplicate this and let's get our piece 1. So rename this to piece 1. Let's get one more, and then let's select this piece 2. That's it. And then we're gonna put this to a collection node. In here, I'm gonna just say instances collection, and then the collection is instances and star to select everything. So inside this instances, we're gonna select every primitive, every component that we have. So basically this is our collection for the instancing. Let's create a instancer node, and in this instancer, what we need to do is we need to first of all connect this to the second input for the possible prototypes, and then in here prototype primitive, you can just select here collection, instance collection. And the cool thing is, if you inside create a scatter node and go back, cool thing about this is let's also create a simple p-scale here, right? And as you can see, they are basically like randomizing on its own, which is pretty cool. You can set something like an index attribute here to randomize those, but we are not gonna do that because we don't really want this stuff here. What we want is we want to external SOP, and then our external SOP is going to be our points. So if you wait a bit, there you go. As you can see, those have different orientations, different sizes, and they all look quite nice, quite cool. So let's create a material library. We're gonna assign some of the materials here. We're just gonna say Karma material builder, and then this is our instance material. Inside, I'm gonna use Karma Primvar reader. So basically what I'm going to do is I'm going to take the, if you look at this, these have its own color. So we're going to somehow get this color back on our primitives. Let's actually switch this to the Karma CPU for now, because the CPU is CPU is faster, but later we're going to switch to Karma XPU. Now we need to assign this material, right? So to assign this material, you can do this. Just click the after fill and then assign to geometry. And then geometry is going to be these instances. So you just like take this and then move it here. And if you wait a little bit, there you go. So it's updated, and then now it takes this material right here. So we want to make this metallic, and we'll also lower down a little bit of the roughness here. And then with this Primvar reader, what you can do is you can switch this to float 3, which is our color. So let's call this display color. How like display color is called in the Solaris network. Let's connect this to the base color. And if you wait a little bit again, now as you can see, you get your color back to those primitives. It's kind of slow because it's CPU right now. Let's also create a color correction node, which you can use to like a shift hue of those, and then adjust gamma a little bit if you need it. Just make this a little bit more greenish, as you can see. Next up, what I'm gonna do is we're gonna use a merge node, and we're gonna create a camera. Let's create a camera. Let's connect this up, and then in the camera, I had a really simple camera, so it's like a little bit high right there, and then I also just rotate this 90 degrees. So if you look into this camera, just wait a little bit, please, Karma. Okay, there you go. So it's just on top. And then what I did was I just aspect ratio is 1:1, and then the aperture is 36, and then the focal length for me was 100. But this is kind of what I had. So in the sampling, I'm gonna set this shutter open and then shutter close a little bit lower. This is basically the amount of motion blur that you have. And then the focus distance I'm gonna set to 10 because I'm just gonna focus on this one point here. And then the f-stop is 0.15 in my case. And also a cool thing is that you can use a lens shader, and let's set this to set or create, and if you press this button it automatically going to create a lens shader for you, which is pretty cool. And let's create a lights. The last thing we need is lights. What I did was I used a one dome light which was set to this HDRI that I had. I lowered down I rotated this a little bit and also lowered down the intensity. But now it looks weird for some reason. I'm not sure why. I'm not sure what's happening. Let's create the Karma render settings. Switch this to XPU and then switch here to XPU as well. Okay, now it's a lot more faster, and we also have our depth of field. As you can see, why this weird thing is happening. Oh, because we don't really have an HDR here. So I'm gonna, it was my bad, my fault. Right now it should work just fine. Let's just wait a little bit. There you go. So now it's fine. Let's turn off the lights. We turn off the grid as well. And as you can see, we're getting somewhere, but we need one more light, which is going to be like a directional light here. I'm gonna just put my settings into this light. You can create your own, it doesn't really matter. So my setting was like this. So 1.65 minus 0.75 minus 13 minus this. And also what I did was I created in the light, in the properties, just like 20 and exposure to 1. And the cool thing is that you can set this in the type. Of course you need to set this to rectangular light, and then the width for me was 2. And the most important thing is if you go to the Karma, you can set here a spread for your light. In my case it was 0.15. so this is kind of the light that I had in the scene. That's pretty much it. And also what I did was, as you can see, the bokeh here is just like regular. In my scene what I did was I just used the bokeh shape here. You can do this if you want, but it drastically increases the render time, so I'm not sure if it's worth it or not. But in my scene I actually used this. So if you want, you can use this as well and pipe any like a bokeh image, I don't know, from Grayscale Gorilla or something. It should work just fine. So this is the scene. Let's go to the frame 100. What I also want to do in the parameter, I'm gonna increase the path trace samples here, and I'm also gonna go to the camera effects and then turn on the velocity blur so we get some motion blur in our image. And also for our denoising, we're gonna I'm gonna go basically select albedo, and then in the utility I'm gonna select smooth normal here. So I'm gonna use those passes to composite. And then in the render settings, let's go to the camera render settings and let's set the output path. I'm fine with the default output path actually. So yeah, let's render this. Cool thing is that you can, inside of this, use the render ROP. You can set the monitor and set this to employee monitor. I'm gonna actually show you the final render result of your image. So let's switch this back to Houdini, and then let's set this to render to disk. So I'm gonna render one frame and I'm gonna composite this one frame. This scene is rendered. It's about like 3 minutes. Thing is, this noise is very hard to get rid of. You get somewhat clean image if you increase this path trace samples twice, but of course the render time is also going to be increased. Use a denoising. We're gonna use new cop network to do that. If you create a file node, you can take the render. This is your render basically. Press Shift 3, you can just go to the front view, and then this is basically your image. First thing that we need to do is we need to convert this image from RGB with the alpha. We want to have a RGB to alpha to just RGB. So we want to get rid of the alpha. I'm gonna untick this box here, and then let's use a denoise AI node. In this file node, if you press the add AIVs from file, it's gonna bring in the AIVs that you have in the EXR file. And keep in mind that you are working with the basically ACEs workspace here, so we have to do somewhat color management later. I'm gonna show you that as well. So this is the noise that you get here. So if you pipe this to the albedo, to the normal here, and then the source to the source, and as you can see, it works quite nice. So in this specific scene it looks quite nice. But also what I did was I used a blend node to just basically blend between the denoised image and then the raw image. And what I set was here, I set this to like 0.75, so I bring back a little bit of noise here so it doesn't look that clean. The cool thing about this as well is you can use, for example, this bright node, and because you're working in a ACES color space, you get a lot of dynamic range, which is really nice. So you basically like you can make this scene bright or like, I don't know, dark. So what I did was I just upped this a little bit, maybe even more, and then let's start off by creating some nice glares in here. When I use node called glow, it creates this nice glow. But what you can do, you can set this scale size here to 0, and then what you get is you get this like directional blur here. And then if you just create a reference copy of this node, and then if you press Ctrl Shift, you can delete this reference parameter and then basically just invert this, right? And then after you do inversion, you can just basically add this together. The important part is in this first glow node, you just set this to output glow only, and now you can see you get those glares. So let's increase the threshold a little bit, and let's also decrease brightness a little bit. This is like a first layer, those glows. So let's add this back to our image with an add node. As you can see, looks quite nice, but it's too much in this case. So I'm gonna just lower down a little bit to get this a little bit of glow. And all we need to do is we need to duplicate this setup one more time. Those wires go to output of this add node. And then in this case, we're gonna just adjust a couple of parameters. So first of all, we're gonna increase the size. That's actually pretty much it. And I'm gonna add back those as well. There you go. And then let's just adjust the brightness of this as well. Kinda get this nice glowy things right here. Okay, you get this nice image here. And then next couple of things is what I did was I just adjusted the gamma just a tiny little bit. So I set this gamma to like 0.95, and I also use this chromatic aberration node, and then I just lowered down the global distortion scale to 0.01, and then this is basically our comped image. And right now, if you output it as it is, it's not gonna look right because this is like an ACES view, right? So what you need to do is if you create drop image output, and then if you just pass this in here in the output file, let's call this a particles.png. What you need to do in this node is you need to say bake our open color IO, and then the view in my case is this ACES one. So basically I have a redshift ACES config, so that's why I'm gonna select this view because I'm looking through this view, right? And if you just click to render to disk, it's gonna render this image to this one. It looks the same, right? So this is basically like a comp. You basically just comp the image and bake the ACES, so you can send this to Instagram or something, and it's gonna look fine. And also if you want to make a MP4 out of this, you just save this like as a sequence, right? So you plug your sequence in and then save this as a sequence, then pipe this, I don't know, through a DaVinci or After Effects and just output MP4. That's it. So basically, yeah, that's quick tutorial. As I said, nothing too fancy, but quite helpful for the beginners.